Well, hello Internet, and welcome to my MATLAB video tutorial. In this one tutorial, I'm going to teach you pretty much everything you would learn from a standard 500-page book all in one video, and we will focus in on MATLAB, which is the preeminent environment for scientists and engineers, and I'm going to teach you how to pretty much do anything programming-wise with MATLAB. Now, you don't have to watch the entire video all at one time because in the description underneath the video, I have a table of contents that you can click and learn just about the individual things you want to learn about. As well, I have in the description a file that is a transcript of the entire video as well as a cheat sheet, which is all completely free. And I have a lot to do, so let's get into it. Okay, so here is the MATLAB environment, and I'm basically going to create three files. I have MATLAB tut.m and a shape as well as trapezoid. These are going to be class files, and how you create them. I know you're an intelligent person and can figure things out, so I'm not going to go over all the basics here. Basically, you're going to go new and script whenever you want to create the MATLAB tut, which is where the main code is going to go. And if you want to create a class, just click on that. Okay, and now we will get into the coding. Now, the very first thing that I want to do is I want to keep my output very compact. So I'm going to come in here and I'm going to say format compact like that, and that's all you need to do. And your workspace or your command window might be down here. You can just click it and drag it over to the right side of the screen if you'd like it like that. Otherwise, you can use it the way it is. And if at any time you want to stop execution over here, this is the button you click on if you want to run your code. And if you want to stop execution, you just hit Control C. You have to click there though first. All right, so let's write some code. Very first thing I want to do is demonstrate how to get user input. So what we're going to do is we're going to define our variable name. Everything is a double by default inside of MATLAB. And if you want to get user input, you can say something like input and what's and your name. And you can either come in here and use double quotes or single quotes. Let's just use single quotes just to demonstrate something. Now you see you have single quotes here and single quotes and single quotes. That causes problems. So what we're going to do is just double up the single quotes and all the problems go away. Now I said everything by default is going to be a double. So what I want to do is I want to come in here and say that I want to use a string. So we're just going to come in here like that and do that, and everything's fine. Now you can either use semicolons or not use semicolons. Just understand that the semicolon is going to suppress showing the variable assignments. So from whatever the input is from the user to name, it's not going to show that on the screen. Let's say that I want to come in here and verify that the user actually entered something. What I'm going to do is I'm going to put the tilde inside of here, which is a representation inside of MATLAB for not and empty. And if anything, it doesn't completely make sense whenever we first start off, don't worry about that. As the tutorial continues, I'm going to do things over and over again so you will get it. So I'm going to say if is empty, and then I will say name. So if it is not empty, meaning the variable for name, then I want to print out a message on the screen. So we're going to say print f, and that's just a fancy way of saying I want to print something. And then I can say hello, and then I want to put a string inside of here, which is going to be the name that they entered. So I'm going to go hello and the % for s, and that's going to represent where the string is going to go. And then after that, I am going to come in here like this and type in name, and that is going to print that out. And then I need to end the if statement. So you can save that, and then we can come over here and run it, and you're going to see what's your name. And if I type in Derek like that, it's going to say hello Derek. And if I come in and run it again, it's going to say, what's your name? And if I hit enter, because it is an empty statement, it does not print anything on the screen. All right, so, and we can go Control C to cancel out of that if you would like. All right, so that's some basic information. You can also receive vectors. So let's say we go vector input is equal to input and enter a vector. And I'm just going to use double quotes here just so you can see what that looks like. I can then go and display information out on the screen by just typing in that and vector input like this to output it back onto the screen. And if we run that, what's your name? I can say Derek, and then enter a vector, and I can come in here and enter all this information and go like that, and it'll print it out on the screen. All right, so neat stuff. All right, so that's how we do some basic input and output. Now I want to go step back a little bit and talk about variables. Now variables are going to store data, of course, and they're going going to start with a letter, and then they can have numbers or underscores inside of them. Now, your data types are actually what are called classes, which we're going to get more into later. Don't worry about that. And they are going to have associated methods for working for the data. And you're going to have things like integers, int 8, that's going to be 8 bits of data, and 16, and int 32. And these are just the different data types that you're going to have. Let's int 64. Characters, which are going to be individual characters. Logical, which are like booleans in other programming languages. Double is going to be the default. Single is going to be a representation of a value without a decimal place or a generic integer. And then you're also going to have unsigned types. So you'll have unsigned, int 8, and so forth. All right. So let's go in here and create a character. And you just do this like that. And there you go. Now you have a character. And if you want to go and find out the class for said character, you can do so. And you can see that it outputted it over here on the screen. You're also going to be able to store strings. So let's just call this a string. However, you might be surprised we come in here and type in class, and the string that you have here, it's going to show up as a character. However, if you would come in here and use double quotes, it will change. And you can see that it shows up as a string there. We can go and define a boolean. So we'll say something like 5 is greater than 2. And then let's also go B1 is equal to true. Basically, true is going to be represented with what is called logical 1, and a false is going to be a logical 0. And if you run it, you're going to see that both of those come back as true. Now you're going to be able to very easily see maximum and minimum values you're going to be able to store in your different data types. So let's just go and do an int 8, and then likewise we can go int max and int 8 again. So and do a couple of these guys. Let's say we wanted to get to the largest double that we could possibly store. We just go real max and real max for the single type, which is an integer, and you can see how big these values get or how small those values get. Let's say you wanted to come in here and you have a very long expression you'd like to work out. Obviously this isn't that long, and you wanted it to go over multiple different spaces. How could you do that? Well, you just continue your expression and then go dot 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 like that, and then you would be able to continue going and adding values onto it after that. And you can see the value shows up there in the bottom right hand corner. You're also going to be able to cast to multiple different types. So let's go and create a variable inside of here, which is 8, and let's output the data type that we have here just so we can see what that is. And if you want to cast to an integer 8, remember everything's double by default. You're going to go int 8 like that and throw v2 inside of there. And then you could go and check that the variable value actually changed. Let's go and do a whole bunch of these. You're also going to be able to convert characters to doubles, for example. So you could do v4 and double that and throw a value inside of it, which is a character. You're going to be able to convert two characters. Let's go v5 is equal to character and 64. Oops, 64. Just to do something. And you can see if we run that, v2 starts out as 8, and then whenever we said what is it, it came back as a double. Remember, everything's a double by default. I will stop saying that now. And you're also going to have all your other different data types, and you can see how they change. Okay, so there's an example of how we can do some casting. We'll get a little bit more into that later on as well. And now I want to talk about math operators as well as sprintf. Now basically sprintf is going to format to a string. We used fprintf, which is what we're going to be using for the most part, but just want to talk about this as well. So let's go and get sprintf inside of here, and you're going to be able to represent all kinds of different types of data inside of here. So what we're going to do is we'll say something like 5 plus 4 is equal to, and if we want to put an integer inside of there, we just put the % with a D, and then we can throw a new line inside of there as well. And then we can go and actually take the addition here, and it's going to be transposed the value here directly inside of there. And if we run it, you can see the result that shows up on our screen. Now, if you want to use other different data types, let's say we want to use floats, we could go %f, And if you wanted to define how many decimal places, by default it's going to be 4. Let's say you wanted it to be 2. You just put 0.2 inside of there and it will only show 2 decimal places. Likewise, you're going to be able to use exponential notation, and that's just going to be %sign E. If you want to use characters, C. And if you want to use strings, guess what it is? It's S. All right, so, but we're going to mainly just be using fprintf in this tutorial. Just wanted to cover that stuff. Now, of course, you're going to be able to perform all sorts of different mathematical calculations. Let's go over a couple more. Here, let's do a division. And then in this situation, if we want to show as a float, we just put F inside of there. Like I said before, if you want to go and only have it be 2 decimal places, that's how you do that. And then we can go and put a division inside of there. And that's not it. There are so many more. Let's say you wanted to do exponentiation. You could just go 5, 4, and let's go put this guy inside of here. And then we'll just change this as well. This is where our output, our calculation is going to take place. And there's also modulus. So modulus will just give you a remainder of a division, and we'll put a %sign in there, but that's going to cause a problem because %signs are used for these little guys. So what we're going to do is just double that up, and then we will not have any problems. And this is going to be a decimal as well. However, you're going to have to use mod and 5 and 4 to be able to do that calculation. And let's go and execute it, and you can see the results of all those. And another thing that would be very useful is, let's say you wanted to generate a random value between 10 and 20. You could do so, and of course store it in a variable, but I'm not going to do that right now. So we'll just go 10 and 20, and there we are. And you can see it generated 17. And answer, whenever you don't provide a variable, it automatically gets stored in a variable called ANS. All right, so there's this. It's also important to understand that precision is accurate up to 15 digits by default. Of course, you're going to be able to increase that if you'd like, but I just want to demonstrate that here for you. So we went and threw in big giant digits inside of here, and if we run it, and if you go and calculate or go and add up all these different values you see down here, you're going to see that the precision by default messes up after the 15th digit. Okay, so there's just some basic operations as well as a demonstration of printing to the screen. And now I want to talk about some default math functions. Now, if you want to see a whole bunch of different math functions, you can just type in help and then ELFUN over here in your command window, and you're going to see a ton of them. Okay, these are all built in the elementary math functions. There's so many other different math functions though, of course, and you can go through and play with those on your own. I went in here and threw some of the very, very common ones that you're going to use over here, and let's go and execute this, and you can see exactly how it all runs. There we are, and all of the results of these different types of calculations that you can perform. All right, I'm not going to get that much into the built-in functions. I just showed you where to find them, and you can go and play with those on your own. But instead, now I want to talk about conditionals. Now, with programming, you're going to want to perform different or execute different code based off of different conditions, and you're going to have some relational operators, and those are going to be, let's spell relational right. There we are. And you're probably going to be familiar with these. You're going to have greater than, you're going to have less than, you're going to have greater than or equal to, you're less than or equal to, you're going to have equal to, and this is not equal to, tilde equals. All right. And comments also, you're going to be able to come in here. There's a comment just by putting the %sign onto there. And you're going to have another comment if you wanted to do a multi-line comment. You just go multi-line like that, and then end it like this, okay? And then everything else is happy. You can do whatever you want. All right, so there's comments. I got that out of the way. And also, we're going to have logical operators. Don't worry, I'm going to demonstrate how all of these work. And with your logical operators, you're going to have OR, which is on the far right side of your keyboard. You're going to have and of course you're going to have not, which we already saw previously. So now what I'm going to do is do some demonstrations. So let's say we have age, and this is an if statement. Perform different code or execute different code based off of different conditions. So what we're going to say here is if the age is greater than or equal to 5 and the age is less than or equal to 6, in that situation, we want to display on our screen that you are, and we got that problem right there. So let's go like this. Remember, if we used double quotes, we wouldn't have that problem. All right, kindergarten. Else if, and then we can throw another condition in. If age is greater than or equal to 7 and the age is less than or equal to 13, in that situation, we are going to give a different message, and I'm going to use double quotes here so I don't have to mess with this. You're in middle school. And we can continue this forever. So we'll say else if age is greater than or equal to 14 and age is less than or equal to 18, in that situation, you are in high school. And then finally, we will have our default, and in our default, we are going to say stay home, okay? And then you're going to always end your if statements and functions, which we'll demonstrate later, with end. And if we run that, you're going to see you're in middle school pops back. And if you don't want age to show up there, you can run it and you'll see that by putting the semicolon on there, that makes that go away. Just want to also demonstrate the logical operators that we have. So let's go and throw true inside of here or false, and then get this out of there. And then likewise, we're going to be able to go and put not true, which is going to go and turn whatever was true into false and falses into trues. Okay. We're also going to talk about the switch statement, which we're going to be used whenever you have a limited number of different options. So we'll say switch age is what we're going to be checking for. And in the case that the age is 5, we can say that we want to say go to kindergarten. And then we can do all kinds of other funky things. Let's say that we want to check a range of different values, say 6 through 13. We can say case, and then we'll go num to cell. We'll get more into cells later on, but you can just do like that. And that's going to allow you to match for 6 through 13. And in that situation, we'll say, let's just say middle school here, just to cut down on time. And then we could also go and have a range of values inside of here. If we wanted to type all those out, we could say 14 like this. And then by default, if none of the other things match, we're going to say otherwise. And in this situation, we can say stay home, just like we did previously. And then we can type in end to end our switch statement. And if we run it, middle school comes back once again. All right, so there's a rundown of conditionals. Now I want to talk about vectors. Now, vectors are either going to be row or column vectors or one-dimensional arrays if you prefer to refer to them that way. So let's go and create a vector. All you're going to do is go and put your brackets here, and then let's say we want to do 5, 3, 2, and 1. There you went and created yourself a vector. Now we're going to be able to find out how many elements are inside of our vector by just coming in and typing in length, and then of course throw in whatever the vector is that you want to check to find out how many elements are inside of it. And there's going to be other tricks we can use later. We can also do sorting. So let's say we want to sort our vector and then store it back inside of it, and that's going to do ascending order. And if you wanted it to go in descending order, you just put a comma inside of there and descend. So I guess now it's in descending order, okay? Otherwise, it's ascending order by default. And you can create ranges for our vectors. So let's go and create another one, and we'll go, let's say we want to have values 5 through 10. There you are. You can create a range with a step. So let's create another vector here. So we'll go 2, and then let's say we want to go from 2 to 10, and we want to do that in steps of 2. That's how you do that. You're then going to be able to concatenate your vectors just by putting brackets inside of here, v2.1 and v2.2, and you're going to be able to get values. However, the indexes start with the value of 1 instead of 0, unlike some other programming languages. So if you want to get this first index in that vector, that's how you do that. Let's run it just to see all the different things. There you can see I created them. There you can see that it's in descending order. You can see there's 4 elements inside of it. You can see I went and created a range of different values. Here we went and did our step 2, 2, 2 the whole way to 10. And there you can see that I concatenated those values. And here we can see that 5 is the first value inside of our vector. We're also going to be able to get the last value inside of the vector just by coming in and the vector that we want, and then follow that up with end. We're going to be able to change values, so we'll just go v2.4 just by referring to the index that we want to change, and we could say that 12 wants to be in there, so there it is. You're going to be able to add values onto the end, so we'll go something like v2 and 11, and zeros are going to be added in to the indexes between, things things that aren't there and the index that you assign here. So let's say we want that to be 33. You're also going to be able to get multiple different values from a vector all at one time. So let's say you wanted to get the first 3 values. So that's how you do that. You're going to use what's called a range there. You're also going to be able to get let's say you wanted to get the second, fourth, and sixth different value out of there. You can do that as well. So we'll just go second, fourth, and sixth, and there it is. And we're going to be able to, let's say we wanted to do a column vector instead of row vectors. Everything so far has been a row vector. Well, let's go and run this just so you can see, and there you can see all the different output. You can pause your screen if you want to take a look at that. And let's go and get rid of all this. And let's create a column vector. So we'll go vt5 is equal to, and to create a column vector, you're going to put semicolons in here between the data. And that's it. Now you got a column vector. All right, so let's say we wanted to create another row vector as well, just so we don't forget how to do that. And there that is. And let's do some vector multiplication, just to do some cool stuff. Now to do vector multiplication, we're going to need a column as well as a row vector. So what I want to do here is multiply the 6th vector 1 by each row inside of my vector 5. So how I would do that is I'd go vt mult is equal to vt5 times vt6. I'm not going to go cover all the different, information on matrices and so forth, but you can see exactly how this all works out with it. And that's how we can multiply vectors. You can also figure out the dot product. Here, let me just talk about dot product. So dot product, let's say we're trying to get the dot product for our 6th as well as our 7th vector. Basically how it's going to work out is we're going to take this value times this value, add that to this value times that value, to get a final result. All right, so let's do that. So we'll go v2 dot product is going to be equal to vt6 times vt7. And if you want to transpose a vector, you just put that little quote inside of there, and that will do it for us. And you're also going to be able to do this in an easier way. You can just go like that and dot product 2. And to get that, we're going to use a function, which is dot. Pretty easy to remember. And vt6 and vt7, and there we are. And if we run it, you're going to see that we get the exact same results on the right side of the screen for either one of those. And let's do a little bit more some math here. And what I'm going to do here is the cross product. To do this, I am going to come in. I'm going to keep doing this with the 6th as well as the 7th vector. And to explain cross product, what I'm going to do is, let's do this demonstration. All right, so let's say we have 2 vectors, and basically how we're going to figure out how the cross product is calculated is we're going to take A1 or A2 in this situation, multiply that times B3, and then subtract from that A3 times B2. All right, so that's the little layout of exactly how cross product works. And to actually go and perform it, what we're going to do is just call the function called cross, and once again pass in the 2 vectors that you want to work with. So there those go, and there those are. And if we run it, you're going to see the results of that calculation. Let's do some other cool stuff. Let's say we want to create a linearly spaced vector. You're going to be able to do that. And let's say we want it to be between 1 and 20. Go and create another vector. This doesn't have to start off with VT, by the way. That's just randomly what I just decided to call my variable. And to do this, we can go line space 1, 20, and 4. And if we execute it, you're going to see exactly how that all lays out. You're also going to be able to create logarithmically spaced vectors, and that's a tongue twister. So let's come in, and to do that, we can go log space and 1 and 3 and 3 and execute that as well. All right, so neat stuff with vectors. And now what I want to talk about is matrices. Now, matrices have both rows as well as columns, which I'm sure you are aware, and let's go and create them. All right, so how you do that is 2, 3, and 4, and then you separate that with a semicolon, and 4, 6, and 8 as a demonstration, and there you can see we created our first matrice. Now we're going to be able to get the number of values inside of a row. Let's call this NRV, and just by using length like we did previously, and I'm going to cover a whole bunch of things here. You're also going to be able to to get the total number of values. This, and how you do that, this guy right there. You can execute it and see the results. We're going to be able to get our row as well as our column size. So do like this by using size on our matrix. You're going to be able to store the rows and columns in different variables as well. So we'll go number of rows, number of columns, and then call size once again. And there we are. And we execute that. You can see the results once again. Let's go and do some stuff with randoms. So let's say we want to generate a random matrix with 2 rows with values between 10 and 20. Well, that's pretty easy. All you're going to do is use the random. There's a whole bunch of different ways to generate random values. I'm just using this one because it's very common. So I said I wanted values between 10 and 20, and I want to generate 2 rows. So there we are, and there we go. And if we execute it, you're going to see we have that. And if we execute it again, you're going to see that it is indeed truly random. Let's say we wanted to change a value inside of a matrix. You're going to use indexes once again. Let's go. I didn't show you how to display it. Let's go and do this and run it. And you're going to see that we're able to get results just by using those indices. Remember, indices start at 1. If you want to change that value, what we would do is come in and do something like that, and that's going to change the value. If you want to change all row values, you could go M2 and 1, comma, and then this guy like that. And let's say we want to change every value to 25. We just did it. If we want to change all column values, do that as well. And let's say we want to do it for the first one, and we want to change that to 36. There we go, did it. We're also going to be able to get our first value in a last row. There's multiple different ways of accessing this information. So we'll go last like this, and then we can go M2 and end. We're going to be able to get the second value in the last column as well, just by messing around with these different things. And last is equal to, and M2, and then we'll put 2 and end inside of there. And let's say we want to delete the second column. We can come in and just go M2, and then assign it no value, and throw a semicolon inside there. And if we run it, you're going to see everything in regards to the results that we have there. All right, so I'm going to do a ton more with matrices here in a second, but first I want to talk about looping. Now we're going to use a for loop, and it's going to temporarily assign values. Let's say we want to use a range from 1 to 10. It's going to assign that to our I value, and like this, and end, and there we are. And if we run it, you're going to see our results. So that is how to use a range from 1 to 10. We can do all kinds of other things. Let's say we wanted to decrement starting at 10. So to do that, we could go 10 like this, and then we wanted to go downwards by 1 each time through, and then change this to 0. Likewise, we can do that. You can also specify values you want to loop through. So let's go like this, and 2 and 3 and 4. There we go. You also can cycle through matrices, well, which of course is very useful. So let's go and do 2 and 3 and 4 and 4 and 6 and 8. And here we'll use nested for loops to cycle through this. So we'll go for I is equal to 1 through 2. And then inside of it, we'll go for J is equal to 1 and 3. And then we want to display our results by referencing those indices. So here we'll go I and J, and always make sure you have exactly the same number of parentheses on the left as you do on the right. Of course, we have to end these guys. And let's go and do another demonstration. Let's say we want to cycle through a vector. You can also do that. So 6 and 7 and 8. And then we can go for I is equal to, and let's say we want to start with 1, and we want to go through the length or the size of our vector. Well, there we go, and we just did it. And then of course we can go and display those results. So I vector, and then throw I inside of there, and then of course end it. And if we run it, you're going to see our results. Okay, cool stuff. All right, so now what I want to do is talk about while loops. All right, a while loop is going to continue executing as long as a condition is true. So you're always going to have a value created before your while loop. And what we're going to do here is we are going to say we want to only print out even numbers. So I'm going to say while I is less than 20, then I'm going to use modulus to check if a value is is even or not. So I'm going to say I, and 2 is going to be, I'm going to divide by 2, and if that is equal to 0, well, in that situation, I then know I have an even number, and I want to output it onto our screen. Now, MATLAB doesn't have things like if you want to increment a value, you can't do this, or you can't do this like you would do in other programming languages. You have to type this out. Don't know why, but whatever, it's not that big of a deal. And we'll go and we will increment I plus 1. There we go. We're incrementing that value right there. And let's throw a semicolon in because we don't need to see that. Now, if we want to continue back to the beginning of our while loop after we do this and not execute any more code, we can just type in continue, and that's what continue does. Otherwise, we will increment the value of I once again. Then let's say I want to prematurely end the execution inside this code. What I can do is I can say if I is greater than or equal to 10, for example, and then I want to leave the loop, I can type break. And what break will do is jump completely out of our code, or out of our loop, and jump down here to like line 15, as you see right there. And you can see right here that we only printed our even values. And there we go. And that is our while loop. And now what I want to do is jump over and talk more about some more advanced matrix functions. Okay, so matrix functions. I went and created a couple matrices here. Okay, so let's go. Let's go. You can add matrices. You can multiply them. You can pay special attention to the little period you have there. And let's do a couple other ones. There's functions, for example, can perform operations on all values. So if you go and do like square root, you'll perform square root on everything. 3 times 2 also, just to demonstrate that. And you can see here how all these different calculations show up here on our screen. And I can go and get rid of these things just by putting semicolons just to clear up our screen a little bit. You're also going to be able to sum all of your columns. So there's M3, and you can form matrix multiplication. And let's go and create 2 more matrices just so I can demonstrate this a little bit better. Of course, whenever you're performing the multiplication, your columns of M6 must equal the rows in M7. So let's go M8 is equal to M6 times M7. And you can see how that works out. And if you're at all confused by what's going on here, let's say we have M8. The way this is going to work out is your first index is going to be actually equal to 1 times 1 plus 2 times 2 and plus 3 times 3, which is how we are able to get 14 on this, specifically in this little area right here. You're also going to be able to check how many values are, let's say, greater than 3, for example. So greater than 3 is equal to, and we'll do this on M4. We can, let's go and do another sum on this, greater than 3M for all. And this is how we would be able to find out how many of those values are greater than 3. And you can see here that we got a logical array or Boolean array, however you want to refer to it. You could also come in and check for equality. Obviously, these are not equal, just by going is equal and then passing in the matrices. You'd be able to find matching values. So let's say we go find for M3 and those values that are greater than 24. And you can see right here that we come back with only 12 because there's the 32 and everything else is less than 24. You're also going to be able to multiply your column values with product. So let's just go M3 like that. We're also going to be able, what's called cumulative sum. And the way this works is the first row stays the same and each after is a sum of the preceding as well as the current row. So we will, let's go and use M3 once again. And why don't we do it in reverse? If you don't do it, if you don't put reverse inside of here, then it obviously goes in ascending order. And we can also go sum with just regular M3 for example as well. And there you can see how those all work out. You're also going to be able to do cumulative product. And so we can go in reverse as well. So we'll go cum product. And of course that's multiplying each row consecutively. And also let's say that we would like to go and flip. So if you would want to flip the first column with the last, you can go flip and LR for that. And then you can also flip rows. So we'll go flip UD and throw that matrices in there as well. You could also rotate 90 degrees, and it's actually very useful. Maybe I'll give an example later on how to use that. You're also going to be able to rotate 180 degrees by just coming in, throwing 2 inside of there. And you can convert into a 2x6 matrices, for example, by using reshape. And again, throw that in there. And then how you want it to be converted. You can duplicate the matrix into a new matrix. If, for example, you wanted 2 rows by 1 column. And how you do that is that and M3 and what you're looking for. And then finally, the last one I'm going to cover here, I might cover some more later on in the tutorial, but is 2 by 1, and there that is. And there you can see all of the different results. And basically what this guy does, I don't think I said, is it's going to duplicate elements into a new matrix where we have 2 rows for each one value. And you can see 2 rows, 1 value, and you can increase that to 2, and it'll basically make a square of those different values. So there you can see examples of how all of those work out and all of the different matrix functions that are built into MATLAB work. And now what I want to do is talk about cell arrays. Okay, so cells are going to store values of different types. So let's go and create one. You're going to use curly brackets. So we could, for example, come in and create a string and an integer and a vector, whatever you would like to place inside of here. And then you can do things like define the number of spaces if you want to speed up your calculations and not have to mess around with memory a lot. If you want to do that and then add those values in, of course, if you keep adding, it's going to increase, but that's just something you can do. And let's come in and let's say that we would want to get an indice. That's how that is done. And if you have something a little bit more complicated, you could come in, for example, and get the third one inside of there. And by third one, I mean this vector that we have right here. If you want to target the vector and then specifically get an index inside of it, that's how you would do that. You can, like I said previously, add in more information. So let's say we wanted to store inside of here Patty Smith, Doug Smith's wife, too. So of course you're going to be able to use length once again. You're going to see that MATLAB uses the same names over and over again instead of changing them for the same type of feature set across different data structures, which is very nice. And you're also going to be able to delete Patty out of Doug Smith just like that, out of his life. And let's say let's go and output this information. So we can go 1 and we can do length. There it is. And then we can just display each one of those one by one, and how you would display them is like this. And then of course with your curly brackets inside of there to output that, and then of course end this. And let's go and execute it, and you can see all of the different things we got going on here. Pretty cool stuff. All right, what else can we do? Well, you're going to be able to turn your cell arrays into character matrices. So let's go A3 is equal to, and let's go Doug and Patty, and here is a matrix, a character, and CA3, and you can see there they show up. And likewise, you're going to be able to turn character arrays into cell arrays. So is equal to cell str and name that and run it, and there you can see that works as well. All right, so there's some things you could do with cell arrays, and now I want to talk about strings. Now of course strings are just vectors of characters, and let's go and create one here, and I'll call it I am a string, and then let's do all kinds of things with it. Guess what, if we want to get the length of it and the number of characters, we type in length once again. If you want to get a specific character index, you just throw that in there. Of course, it starts at the first index. You can get substrings. You're going to be able to join strings. So let's go like this with string concatenation. So let's take the first string that we have inside of here, that there, since I'm using single quotes, can go in, and that's longer. You can find all index matches for a string. So let's go and say string find, use string 2 and specifically look for A. And whoops, what did I do wrong? Oh, I see what I did. There we go. And there you can see all that shows up over there. Pretty cool. You can replace any matches with just string replace and pass in the specific string that you want to work with. And let's say that I want to go and get longer and replace it with the word bigger. I can bigger it. You're also going to be able to split strings. So let's go and create string array is equal to, and then go string split, and the string you want to split and what you want to split it for. Here I'm going to split it at all of the spaces. So whatever's between those single quotes is where the split will take place. And we can go and check the class for that one. Keep on going here. If you wanted to convert an integer into a string, you can do it, of course. So we just go int to string, and let's throw 99 inside of there. You can convert floats to strings, and then that's just num to string. And let's go 3.14 inside of there. You can compare for equality, string 1 and string 2. And there you can see how those all work out, and you can see that they're not equal. You're also going to be able to check if it's a character or not. So we'll go is letter, and then let's just throw num2 inside of there. You're also going to be able to check if all are letters. String prop, throw word 2 inside of there, and specifically I'm going to look for only having letters, and that's going to give me that result, and you can see exactly how that all works out. If you wanted to be able to check for letters or numbers, what you do is change this guy right here from alpha into alpha num, so that's how that's covered. We of course are going to be able to check if it is a string, so we can come in and just throw some words 2, and we're going to be able to sort. So we'll go sort and string 3. I have a string 3, don't I? No, maybe I don't. Change that to string 1. There we go. And like before, if you type in descend, that's going to sort in the opposite order. You're going to be able to delete white space from both the beginning as well as the end of our string. And then also you're going to be able to switch everything to lowercase as well as uppercase. All right, so there you go. There's a rundown of a lot of different things you can do with strings. And now I want to talk about structures. Now, a structure is a custom data type that's going to allow you to store related data in fields. So let's go and create one. So how you create one is you go struct, and then you would go name, which is what you're going to associate with what follows after it. So this is going to be Doug Smith. And remember, if you want to go down to the next line, that's how you do that. And then we can go and also put in age and 34, and let's say we wanted to have a vector inside of here that's going to have a list of whatever Doug spent at our fake store. There you go. And that's going to have that inside of it. Now what we're going to do is access that data. So how you do that is you just go and type in Doug Smith, for example, and let's say we want to get Doug's age. That's how easy that is. We can add a field. So we can go Doug Smith and just type in wife is equal to, and Patty Smith, he decided to get back together with her, so there we are. We're also going to be able to remove fields. So Doug Smith, and let's say that Doug all of a sudden decided he doesn't like Patty again. He's a very fickle person. We can go and get rid of Doug Smith and specifically the wife part of that structure. We can then check for the existence of a field inside of our structure just by going like this. So we can go see if Doug is currently involved. We can also come in and get a list of all of our fields that we have inside of here. So we'll go Doug Smith. Yeah, I should have picked a shorter name. And likewise, we're going to be able to store structures in a vector. So let's say we want to have a vector called customers, and we're going to, in the first place, put Doug Smith inside of here. And there we go. And then we can go go and create another one for Sally Smith. So Sally Smith, paste that in there, change this to Sally, change this to Sally as well. And likewise, we'd be able to come in and go and get this, and in the second part of customers, throw Sally inside of here. And then of course we would be able to come in here and get that data. So we'll say that we want to work with customers and the new customer, and if we say we want to get the name, that's how we do that. And if we run it, you can see how all of this stuff works out and exactly how all of this information is structured inside of structures. So that's all I'm going to cover about them at the moment. Instead, now I'm going to talk about tables. Now, tables are labeled rows of data in a table format, hence the name. So let's create one. So we're going to go name is equal to, and I'm going to create a whole bunch here. I'm going to create Jim, and I am going to create Pam, and then I'm going to create Dwight. So there we go. We just created a list of names. So now what we're going to do is we're going to go age is equal to, and I'm just going to throw in some random numbers inside of here. So 27, 31, and there they go. And let's say we also wanted to have salary. We can store that inside of here. So we'll get 35,000, and okay, got all that set up. And now we want to be able to use IDs to refer to this information. So, and there we are. Okay, so now what we're going to do is create employees, a table, and throw these inside of here, all this information. And if we want to use a specific part of the table to define the name that's going to be used for each of our individual rows. Well, let's go like this first. We can do that by going row name, and then what immediately follows it is what's going to be used, which is going to be our ID. Now what we'll be able to do is do things like, let's say you want to get the average salary. You can come in and do that. There's so many things you can do, and there it is. And just so you know this, if you ever type in help table like that, see, it gives you a whole bunch of examples of things you can do. And look, I mean, it's just never ending. So, you know, pretty much anything you could want. And let's go and do a couple more of these. Let's say you want to add a column of data. So we'll go employees, and let's say we want to add in vacation days to our employees, and it's just going to go in the order in which they are listed. So it's going to go Jim, Pam, Dwight, exactly like that. And 10 and 14 and 16. All right, what else can we do? We can also, let's say we just want to show two of the individual employees that is inside of our table that equal the IDs of 1 as well as 2. We can do this as well. And then just as a final example here, let's say we want to come in and get employees by name is member, employees, and name, and then the specific names you're looking for. Well, let's go like this again. And let's say we want to find Jim as well as Dwight, and that. All right, and you can see how the tables line up and all of the different information that we were able to get from our tables. So pretty cool stuff. All right, so there's a lot of information on tables. Now I want to talk about file I/O. I'm actually going to leave some of this information in here because I want to show you how to save variables. Very first thing I want to do is show you how to save a matrix into a file. So let's generate a random 8x8 matrix. So random M is going to be equal to, let's say we want values between 10 and 50. That's how we do that. I'm pretty sure I showed you how to do that already. Now let's say we want to save the file as a text file. And what's going to happen is if it doesn't already exist, it is going to create it. And if it does exist, it's going to overwrite it. And this is going to be ASCII, which is just basic text. And just to show that that works, if we want to read the data, what you're going to do is go load and sample data 1, and then we can redisplay that information onto the screen, and it's, you know, exactly like that. All right, what else do we want to do? And let's say we also want to display file data. You can go type and samp data 1, and I think that sounds good, so let's run it. Oh, I forgot to put the dat extension on the end of it. And there you go. All right. And you can see exactly how all of that is created. There's our random matrix, and then we were able to go and pull it out of there and so forth and show it on the screen. Okay, so that's how we were able to save a matrix. Now let's say we want to save variables to a file, like every single variable. Come in and my data 1. That's how that's done. And then what we'll do is we will load all of that data and then display it on the screen. And then let's say we also want to come in and append some data to our file. And whoops, what did I do? Let's just go 1, 2, 3. We just use save followed with append my data and the variable. And there you can see it's showing all of the different variables that we've been working with. All right, so pretty cool stuff. And now what I want to do is talk about functions. Now your functions are going to have to come down at the end of your file, and how you define a function is you type in the word function. You're then going to follow that up with the return variable's name, or return variables. As you're going to see, you're going to be able to return multiple. And let's say that I would like to be able to calculate the volume of a cylinder. So it's going to receive a radius as well as a height. I am then going to store a value inside of the volume, which is what that stands for. A pi is a value that's already stored inside of MATLAB, and then we can perform this calculation, and it's going to automatically return whatever the value is for what we said it is up here. And these are the attributes that are going to be sent inside of it to get it to work. Now what we can do is just come in and go cylinder, volume, and 20 and 30 or whatever you want to do inside of there and run it. Whoops, and I forgot to put the multiplication inside of there. Now we can run it and we can see that we're able to perform that calculation. All right, let's go and do more functions, because there are a ton we can make and a ton of different types we can make. Now what I want to do is cover how if we define, for example, a variable. So I'm going to call this change me is equal to 5. This is the concept of the difference between local variables inside a function. So what we're going to do is we're going to have a function that is simply going to try to change the value of change me, and we are going to see if that works. So I'm going to go like this, and then we're going to create a new function. I also want to demonstrate how to create a function that does not receive attributes, and how you do that is you just go function and then skip the whole equals and return value part. So we called this return or change value, and what we're going to do is call change me, and we're going to try to change that value and see if it works. Based off of how I'm talking right now, I'm guessing that you are figuring out that it is not going to work. So let's come in here and do that, and if we run it, you're going to see the value for change me here is 5, and change me is actually referencing this guy right here, but you can see that whenever we go to try to display the value, it actually comes out as 5 once again. So change me inside of this function is not equal to the change me here. This name here is specific to the function as a whole and ceases to exist once that function stops executing, even though the name is the same. It's a totally different variable, just has a similar name. And that's the concept of the difference between our global values outside of functions in comparison to our local values inside of functions. So hopefully that makes sense. And let's create another one. So I want to create another function, and it's going to be called get random number, and this is going to be another function with no arguments. So let's go and create it, and let's say that random numbers, what's going to be returned, and the name of the function again is get random number. We will go and generate it and return it, and let's say that we want it to be between 1 and 100, and close that off, and then end once again and run it, and you can see here it generated a random number. Let's say that now what we want to do is return more than one value, And what we're going to do is we're going to say cone volume and cylinder volume. This is going to return both of those values, and I'm going to call this get volumes and pass in 10 and 20 inside of there. And then for the function itself, I'll go function, and I'm going to be returning two values, so I am going to define that in our function definition. Cylinder volume is equal to get volumes, and we'll get past a radius as well as a height and calculate both at the same time. And then what we can do is just come in, and it doesn't matter in what order you do these calculations, by the way. And then we'll go pi times radius, and then multiply this times our height, and then come in and do cone volume is equal to 1/3 times our cylinder volume, and then we'll end that function and run it, and you can see that we were able to perform and return both of those values. So neat stuff. So you were able to receive more than one value. Let's see how we can set it up so that we can accept a variable number of different arguments. So I am going to have the sum. This function I'm going to create is going to sum a random number of values. So there it is. That can be as many values as I would like. And then we'll define the function down inside of here. It's going to return a variable named sum, and it's called getSum, obviously. And if you want to receive a variable number of values, you just type in var origin like that, and then we need to give sum a value ahead of time. Let's go and not output that. And then what we're going to do is we're going to cycle through the values that were passed inside of it, and just pass that there. There you are, to get to the total length. And then we can just come in and get our sums. So, and how you get those is like this, and then 1 each time, and we don't need to output that. And then we can end our for loop and end our function as well, and then run it, and you can see that the sum comes back as 10. And no matter how many different values you pass inside of there, it's going to work. So neat stuff. But how can you go and return a variable number of values? So let's say we create a function that's going to generate a list of numbers. So we can come in and we can go get numbers, and let's say we want to get 10 of them, and we want them to automatically come back to us. Well, we can go function and var work out this, and the name of our function is get numbers, and we're going to get that value passed inside of here, and then we are going to generate them. So we'll go for k is equal to 1, and how many values do they want to generate, and then we just have to store them and then return them. So once again, 1, and then we will, in this situation, put the k in the second part, which is going to be equal to k, and we can do anything we'd like with it. And then we close the for loop and close the function. And there you can see we were able to come in and generate those values as well. So pretty cool stuff we can do with functions. And guess what? We're not done, because now we're going to talk about anonymous functions. Okay, so anonymous functions are basically just one-line functions. And how you define them is you come in here and you give the name of the function so that we can refer to it is equal to, and then you put @ symbol, and then the attributes that it is going to receive, like length, width, and height. Then following that up, you have the function body, which is just going to have everything we have here. There we are. Now what we'll be able to do is, let's go CV is equal to, and cube volume, and then pass in the values for our function. And there we are, and you see that that comes back as 4 for no apparent, oh, I see, because I didn't put L there. And there it is. Now it's 8. All right, so that's an anonymous function. And now let's do something cool, which is I'm going to show you how to pass a function to a function. So I'm going to create an anonymous function right here that is going to multiply a value times 3. What's it going to do? We're going to go at, again, it's going to receive a value of x, and then the function body is just going to be that it is going to multiply times 3. We can then go solution, and we're going to create a function called doMath that we're going to pass our function into. So we'll go mult 3, there's the function, and then 4, which is going to be the value that is going to work with. All right, so now what we can do is come down here and go function, and solution is equal to doMath, and it's going to receive a function. No, you don't have to use func there. You can use whatever you want. It just makes sense to me. And then solution is equal to, and func, and the number that is passed inside of it, and then end it, and then run it. And you can see a cool way of passing a function into a function. But you may ask yourself, well, if we can pass a function into a function, can we return a function? Of course we can. And I'm going to go multiply 4 is equal to do. I'm going to create a new doMath function. I'm going to call it doMath2, and there that is. And then solution 2 is going to be equal to mult 4 and 5. So this is going to generate a function that is going to allow me to multiply times 4. And then I'm going to use it to prove that it works. All right, so let's create that function. And you just go function and do math2. It's going to receive a number, and then it will return a function. And we're going to create a function, and you can see right here it's an anonymous function once again, and the function body itself. And then we can end that, and it's automatically going to return it. And if we run it, you're going to see that that works as well. So cool stuff with functions, and we're still not done because we're going to talk about recursive functions next. Actually, before recursive functions, I want to talk about something else, which is eval or evaluate, and what it allows you to do. Then I'll jump into recursion. All right, so what eval does is it actually allows you to execute code that is saved as a string. So I'm going to call this to execute and equal to Sprintf, which we covered previously, which generates a string. So here what I'm going to do is I'm going to say total is going to be equal to, and this is plus and d, and close that off, and then I'm going to go 5 and 4, and there we go. So that is our string. Now what we're going to be able to do is call eval, and you can do this with any, type of code to execute it. It's sometimes dangerous to do, but whatever. I just wanted to show you just to cover everything, and you can see right there that it was able. This is whenever the string was created, and here is when it's executed. All right, so cool beans. And now I will talk about recursion, and that is just whenever a function actually physically calls itself. So let's create that function, and we're gonna go and calculate factorials. So I'm gonna call this factorial number. That's what it receives. And every recursive function must reach a point. If it is a function that calls itself over and over again, it must reach a point where it no longer makes a function call. So we're going to say if num has a value of 1, then we are going to say that val is equal to 1, and it is no longer going to call the function itself. Otherwise, the value is going to be equal to num times the factorial num minus 1. So you can see right there, this num is going to slowly get to the point where it is equal to 1, and then it's going to stop execution. So let's end that and end that. And now what we can do is come up here and we can go factorial of 4 and execute it. And you can see it's equal to 24. Now, if you're confused about how that works, this is basically how it works. All right, so we're coming in here, we pass in a value of 4, then we go and get 4 times factorial of 3. And that eventually is going to be equal to 6. But to calculate that, we come down here to this guy right here. That's where the 3 goes. This guy right here is the factorial 3. And again, we decrement the value of num to 2, and we get this point right here, and then we come down here. And this is the part where we start returning values, because 2 times factorial of 1, as you can see right here, is going to give us a value of 1. It's going to be multiplied times 2, and this is when we get our first result. After we get that result, this result jumps up here, and and we get our second result. After we get our second result, this jumps up here, goes to the 6, and that's how we get our last result and our final answer. All right, so quick demonstration of recursive functions. Now I want to talk about the object-oriented part of MATLAB. Okay, so basic understanding of object-oriented programming is that real-world objects have attributes such as height and weight, as well as capabilities such as the ability to run or eat. Classes model real-world objects by storing attributes as something called properties and model capabilities using methods. And of course, I'm going to show you a whole bunch of examples. Basically, a class is just a blueprint that creates objects, and classes must be created in their own file with a class name that is equal to the file name. Now I'm going to show you an example. So here is shape, and let's open it up and let's create it. So basically, to define a class, you go class, first off, the name shape.m, okay? So class definition, and it's going to be called shape, exactly the same. Then what you need to do is define your properties. So I'm going to say that every shape is going to have a height as well as, well, let's change that to, well, not weight, width. So there we are. So that is going to define our properties. Then what I'm going to do is I'm going to show you static methods as well as properties. Basically, static methods and properties are going to be shared by all shape objects. So if a property for a static property changes, it's going to change for every single object. So what I'm going to do here is I'm going to define this, and you have to put your static methods before your non-static methods inside of your class definition. So I'm just going to create a function here, and what it's going to do is either allow for the setting or the getting of the number of shapes that have been created so far. All right, so I got that set up. So what we're going to do, if you want to say that a property is going to be shared by all objects, you put persistent inside of here, and I'm going to give that the value var. Then what I want to do is I want to give var a default value if it doesn't already exist. So I'm going to say if is empty, which means it doesn't have a value for var specifically. I want to say var is going to get a value of 0. Then end that if statement. Then what I want to do is if I receive a value, I want to assign it, and otherwise I want to return it. So I'm going to say if nr var, whoops, that's not right, put a space inside of there, there we go, is equal to var plus data. I'm going to pass a value of 1 inside of here each time I create a new shape type. Okay, so end that if statement. And then after this, I'm going to say out is equal to var. And then I'm going to end that function, and then I'm going to end that specific block of my class definition that is assigned to static methods. Then I'm going to come in and create more methods. So the very first one I'm going to do is create a constructor, and this is going to be called every time a new shape is created. So I'm going to just create the function. So object is equal to, and the constructor has the same name as the class and object. So height and width is going to be passed inside of here, and then I'm just going to assign it. So that is it. It initializes or defines the basics of every shape that is ever created based off of data that is passed inside of it. That's what a constructor does. And this is just going to be width as well. Then I want to increment the number of shapes being created. So I'm going to go object and set get num shapes and pass 1 inside of there by closing that function and creating another one. Now what I want to do is I want to overload the display function that all objects receive. So I'm going to say if display is called on my object, what I want to do is change it. And how I'm going to change it is I'm going to print this instead. So now what I'm going to print is height, and then put this inside of here. I'm going to say I want 2 decimal places as a maximum, and then I'll go width. This isn't division, this is actually just a separator. And then do another one inside of there, 0.2f, as well as a new line. And then I'm going to jump down to the next row. So 1, 3, and down here I am then going to get those 2 values, put them inside of there. So this is how we were able to overload a function. I'm going to show you another way to overload stuff, which is very useful. And then I'll end that method or function, whatever you want to call it, same difference. Let's say that we also want to be able to get an area. So I'm going to say function and area is equal to get area, and object is automatically going to be passed in whenever you call these functions, as you will see. And what I'm going to do is just go object height times object width and return that, and then end that function. Another thing you're going to be able to do is overload your a whole bunch of different operators. What I'm going to show you is the greater than operator, and in the code in the description I'm going to show you a link where you can see every single operator you can overload. But if you want to overload the greater than function, this is just going to stand for true or false, is equal to, you use GT, and then you're going to have object A as well as object B. And then inside of here, I can define how to define if one is greater than the other. So here I'll go TF is equal to object A. And if you want to call the function inside of here on this object, that's how you do it. And then you can go object B dot get area. And this is this function here. This is what I'm calling. And then we can end that function and then end our definition of all of our methods that we have inside of here, and then end our class definition. As you can see right there, it did. All right, so neat stuff. And now I'm going to jump over and I'm going to show you exactly how we can create objects. So here we are. And I'm over in the MatLab tut, file that we've been using the whole entire time. So let's say I want to create a new shape. I just call shape, which is the constructor that we created, and just throw in some dummy values. I can then go display so that we can see what the overloaded display function looks like, and then go shape. Also show you what it looks like whenever we go and try to figure out how many shapes have been created. That's also how you call static class functions. If you were wondering, just put the name of the class in front of it, and there you go. And we can also call get area. You can see that our display function thing worked really well as we were able to come in and calculate our area and the number of total shapes that have been created. Go and create another one just so we can see that this is all working. So throw that inside of there, and let's change this to 2, and let's change this to 5 and 10, and display 2, and and now you can see that we went and created even more objects. And you can also see that that automatically worked. All right, so now what I want to do, oops, you know what? I'm also going to come in and go A1, is it greater than A2? And we can see that that overloaded function works, and you can see that it comes back as true. All right, so now I got that set up, and I'm going to show you how inheritance works. So I'm just going to come over here, whoops, right click, new class. Guess I should have showed you that before, but whatever. What we're going to do is we're going to call this trapezoid. So trapezoid, and there it is inside of there. And then we're going to open it. All right, and you can see a whole bunch of things showed up here automatically. I'm going to get rid of it just to clear up the screen a little bit. Of course, it's a good idea to put tons of comments everywhere, but I'm working with limited real estate. All right, so if we want to inherit all of the properties and methods that are inside of shape, what we do is just go like this and type in shape like that. It automatically works as long as they're in the same file folder. What I want to do here is I'm going to extend it. I want to have another width so that we can work with trapezoids. And to do that, I just put that there. And then I'm going to use the trapezoid function we have here. So let's go and get rid of this. And I'm going to put in height as well as width too. And then I can come in and go object. And if I want to call the constructor for shape, which I inherited from, I just go like this and shape and pass in height and width, and it takes care of initializing those for me, which is useful. And for the thing that doesn't exist in shape, which is width 2, I am then going to come in and go width 2 and assign that value. All right, and that's all I need to do for the constructor, and it's automatically going to calculate the number of objects created and all that. Now let's say I'd like to come in and overload or change the display function because it no longer works for me, I can do that. So I'll just go display and object, and then go and change this up a little bit. I'm going to jump over here and get this. So I'm going to use basically the same exact code. So let's just copy it and paste it inside of there. And in this situation, I'm just going to have an additional width. So after we have this guy inside of here, I'm going to come over like this and go width 2 and paste that inside of there, point to F, and everything else is perfectly fine. And then I'll just go object and width 2, and then I'm also going to have to change the way that we calculate area. So I'm going to go function area is equal to get area. So I'm taking what I like and I'm changing what I don't like, and then I can go area is equal to and object height divided by 2 times object width plus object width 2, and there that is, and then end the function all together. And now I can jump back over into here and we can work with this stuff. So let's go and create a new trapezoid. I'm going to call this A3 is equal to trapezoid, and 10 and 4 and 6 this, and then we can go display just to verify that that changed like we wanted, and then A3 gets area just to verify that that changed. And there you can see that we were able to perform both of those calculations. So neat stuff. And the last thing I'm going to do is I'm going to do a brief overview of plotting inside of MATLAB. All right, so I could do a 2-hour video just on plotting. So I wanted to be heavy on the programming, a little less heavy on the plotting part, but I am going to give you a couple examples here. All right, and if you guys really want me to do more on plotting, leave some comments and I will do it. Okay, so I'll just create some vectors here. Vowels, let's call it 2 is equal to 1, 5, 7, 6, 8, and then we're going to start some stuff. Okay, so let's say I want to create a window. Windows are just going to pop up on the screen. And I want to create a window. Let's say I want to create 2 windows. And one of them is, I want it to be called figure 1. There that is. And let's go and do a plot. Of course, you're going to be able to come over here and go help. This is actually fun. Playing around with the different plotting techniques is a lot of fun. Just help plot. Look at all this stuff you get. Okay, so there's all kinds of stuff. And then you can see all the different tools and things down here. So neat stuff. All right. So what I want to do is I want to plot my X values that we have here and Y values. And then I'm going to say that I want this to be green. Hopefully that shows up on the screen. And what this is going to do is a green dotted line with pluses at the points. So we'll do that. And I can change the line width as well to make sure that it sort of shows up on the screen. And how to do that is I go line width and then follow that up with 2. And the colors, here's the colors. So this is green, G, that's that lined up with this. Okay, so there's some colors you can use. Here's your plotting symbols and here's your line types. So I chose to use this guy right here for the actual points, and I am going to use this guy right here, and that is going to be represented with a dotted line. Okay, so we got that there. I'll just leave that on the screen so you can see it. And if I want to draw over what I just plotted, I can just go hold on, and then we can do another plot. And here I'm going to say plot and X values and Y values 2, and then I'm going to say that I want to change this to black with stars for those specific parts, and there it is, and there that is. Okay, I can then also define a legend that's going to define what is going on. So I'm going to say Y values, and it's going to show like a representation of the different line changes or the dot changes that I defined also inside of there. And that's how you create a legend. And that sounds good. Let's run it. And there you can see it showed up on the screen. Okay, so there's your plot, there's your legend, there's those individual dots that I talked about, and so forth and so on. So very, very simple plot. You can do excruciatingly complex plots inside of MATLAB. Let's go and create another one, just a bar chart. So if I want to turn the grid on in my next one, that's how you do it. And let's say I want to define the X label to be equal to days and Y whoops, y label equal to money, and title, I'm just pulling this out of my head, money made today, not doing very well here. Let's just throw that in there. And then I'm going to create a new window. And how I do that is go figure 2. And then let's create a bar chart. So it's just going to be X values and Y values. And let's make the color of the bars red. And then is there anything else I want to do? Not that I know of. All right, so that looks good. And let's run it. And you're going to see they both show up. Whoops, undefined function or variable line 19. What did I do? Well, you can see the other one showed up. There's figure 2. It's going to show up and it's going to be a bar chart here in a second. Ah, this is Y values. So run it. Looks like it worked. And you're going to see that the first one showed up as well as the second one. Okay, so cool stuff. Hopefully you guys enjoyed this tutorial. I had to spend a lot of money making it, so hopefully people like it and watch it. And like always, please leave your questions and comments below. Otherwise, till next time.